morning. My name is John Agesa, a teacher of math and integrated science, stationed currently at PCL Langata School, and I'm honored in this class to take you through Algebra, grade 8. Basically, we'll be looking at how to factorize algebraic expression, and that will be the main aim of this class. So by the end of this class, you should be able to do three things. That is, one, you should be able to factorize algebraic expression with two terms. Also, you should be able to factorize algebraic expression with three terms. And finally, you should be able to factorize algebraic expression with 4 terms. So to begin with, back in grade 7, we looked at the difference between an algebraic expression and an algebraic equation. So to begin with, back in grade 7, we looked at what's the difference between an algebraic expression and an algebraic equation. So by now, I expect you to be able to tell the difference. But in this class, we'll not be concentrating in algebraic equation. Rather, we'll be concentrating on algebraic equation. So there are different types of algebraic equation. We'll be looking at a simple case of algebraic expression, and a good example of an algebraic expression in this case is this expression written here. That is 12k minus 6 So we're going to look at how do you factorize such an expression, that is 12k minus 6. And for you to factorize this expression, first of all, you have to identify how many terms are in this expression. This is an expression with, So in this expression, we have 12k minus 6. And the first thing is, once you've identified how many terms are there, where in this case, we have only 2 terms, that is the 12k and the 6. So the first things for you to do is you're going to get the GCD of the two expression. So we are having 12k, and the other side we have a 6. We're going to obtain the GCD of the two terms, and we're going to look at which is the smallest number that can divide both the two terms. So I'll begin by dividing both sides by 2, which 2 will divide 12 6 times 6k. The other side, you're going to get a 3. And also, we can see there's no any other small number apart from 1 that can divide 6k and 3 completely. So we are going to take our GCD as 2. Once you've obtained your GCD, the next thing is you are supposed to divide every term in your expression by the GCD. So initially, our expression was 12k minus 6. We are going to divide all the 2 terms in this expression by the GCD, which is 2. So divide this side by 2, divide the second term by 2. And you also multiply everything by the GCD. So for us to multiply everything by the GCD, we are going to enclose our equation with brackets and have a 2 as a coefficient of that expression. So on simplification, the content inside the bracket, this 2 will divide the 12 6 times, and also this 2 will divide the 6 3 times. So your final expression, once you've simplified it, you're going to get 2 into bracket 6k minus 3. Now, you're supposed to be able to see that that's a good thing that usually comes out when you're factorizing algebraic expression is that on the table where you're getting the GCD part, that part is always supposed to be identical to your content inside the bracket. So that's our first case on factorization of algebraic expression. It's a simple example, and we're going to move ahead and look at other complex example as we proceed. So with our example 2, we're going to increase the complexity of our equation by introducing more unknowns in our equation. So we're going to look at an expression of this format where we have 10 P, Q, not 10P, rather 10P plus 5P, Q. And we are supposed to factorize that expression also. So what you're going to do, you're going basically to repeat the same thing what we did initially. So our first thing is, because this is an expression with two terms, we are also going to obtain the GCD of the two terms. Our first term is this part here, and our second term is this part here. So we are going to obtain the GCD of the two terms. I'm going to have it in a table where my first term is the 10P, and the other term, the second term, 5P, Q. Okay, thank you. So for us to get the GCD in this case, we are going to also identify which is the smallest number that can divide both the two terms completely. So first of all, we are going to evaluate the numerical part of our terms, that is the 10 and the 5, and look at which is the smallest number that can divide both the two. So 2 cannot divide all the two, rather the smallest number which can divide both the two numbers and not end up with the remainder will be a 5 in this case, where 5 will divide 10P, 5P, and 5 will divide 5PQ, PQ times. Now also, once we are done with the numerical part, we are supposed also to move to the other part, that is the part with the unknowns, and look at is there any letter that can be used to divide both the two parts. So we can see that there's a P that's appearing on the first term, and also there's another P that's appearing on the second term. So it indicates that we can make use of P to eliminate this part. So P can divide this number, and also P can divide this part. So if I was to divide this part by P, I'm going to obtain this 5 and this one as a Q. And in this case, my GCD will be the product of 5 and P to give me a 5P. Once I've obtained the GCD, I'll repeat basically what we did here. We're going to take our terms in the expression. So our original expression was at 10P plus 5PQ. So we're going to divide every term in this expression by the GCD, which was this number here. So divide this one by 5P, also divide the second term by 5P, and multiply everything by 5P. So for us to do that one, we're going to enclose our expression in bracket and multiply everything by 5P. So on simplification on the parts inside the bracket, I'll start by simplifying the numerical values, where this 5 is going to divide this 10 2 times, and also this 5 is going to eliminate that 5. If I was to move to the other part, this P is going to eliminate this P is going to eliminate this P, such that your final expression becomes 5P into bracket 2P plus Q as your final expression. Sorry, this P was removed from the cancellation. This divided by this one. So you're only left with 2 and Q as your content of the inner part of the expression. And we can still see it's still retaining the same idea from what we had initially. Now to move to our third expression is now we're going to introduce expression with squares and powers in our expression, so that we can look at then how do we factorize other types of expression from this kind of expression. So in our first expression, we just have an unknown without any square. Likewise, in the second expression, all our unknowns, the letter parts, none of them had a power or a square of that sort. But for us to look at our final example in this first part, we're going to look at another different kind of expression, which is equivalent to 3xy squared plus, it's a subtraction, 12y. The 12y is not squared, so we are supposed to factorize that algebraic expression. And again, we're going to repeat whatever we've been doing. So the first thing will be for us to get the GCD of the two terms, and we're going to begin by drawing the GCD table, where our first term will now be okay. So our first term will be equivalent to 3xy squared, and our second term will be equivalent to 12y. So our GCD will be equivalent to 3 times y, which will be equivalent to 3y. So once you've obtained the GCD, you're going to take the GCD and divide everything by the GCD. So from the table, we are getting the GCD as 3y, and we're going to get the GCD now, divide every term that we had in the expression by the GCD. So our first expression, 3xy squared minus 12y. So I'm going to divide this first term by the GCD, which is 3y. Also divide the second term by the GCD, which is 3y. So I'm also supposed to multiply everything by the GCD, which is 3y for that case. Now I'm going to simplify the content inside the bracket, where the y will drop off the y. Also this y will now remove the y squared. To move on simplification of numerical value, 3 will divide 12 4 times, and this 3 will completely cancel off this 3, so that your final expression after simplification will be a 3y into bracket xy minus 4. So basically what we are doing when you're factorizing algebraic expression, first of all, if it's an expression with two terms, you're going to get the GCD of the terms in that expression. Once you've obtained the GCD, you divide everything by the GCD. So all the terms in that expression, if it's an expression with two terms, you're going to divide all the two terms by the GCD, and you also multiply everything by the GCD. Basically, that's what we've been doing here. I want us to move ahead and look at something a bit different from what we've been doing, that is increase the number of terms in our expressions from an expression with two terms to an expression with 3 terms. And my expression that I'm going to use in this case will be this expression here. I have an expression of this kind, 3 okay, yes, 3a plus 12, 3m plus 12n plus 2n okay. So this is the expression that we are having, 3m plus 12n plus 2m minus 3n, and we are supposed to factorize it. So this is an algebraic expression still with 2 terms, because if you have to look at this expression in kin, this expression is not simplified. So first of all, you have to simplify this expression by collecting all the like terms in one side, so that we can add the m together and also do the addition, that is 12n subtract n apart, so that when you are to simplify that expression, your final expression on simplification, you can see that it's now becoming an expression with 2 terms, and the first term will be a 5m, the other term will be now subtract plus 10n. So we are collecting like terms, addition of those two, and 12n minus 2n. So once we have the two terms, we are going to still repeat on what we've been doing. We're going to get the GCD of the two terms. So our GCD table will be equivalent to 5m, 10n. 5 will be able to divide all the two parts. So 5 will divide 5m term, and 5 will divide 10n, 2n times. So our GCD in this case will be a 5. Of course, there's no any other number apart from one that can divide m and n. So once we've obtained the GCD, still we are going to take the GCD and now divide every term in the simplified expression by the GCD. So we are having our simplified version of our expression as m plus 10n divide by now the GCD in this case, which is 5, and the other term. Then you also multiply everything by the GCD for that case. So on simplification, 5 will divide off 5, and 5 will divide 10 two times, so that we talk of our final expression as 5 into bracket m plus 2n. So we are done with all examples on factorization of expression with two terms. I want us to look at the third example, that is the third learning outcome for our case, which is involving factorization of expression with three terms. So my example, I'm going to use an expression with this kind. Three a plus 9b minus 36. So we want to factorize it. So again, factorization of algebraic expression with two terms and factorization of algebraic expression with three terms, basically the same thing. There's no much difference. So basically we are going to repeat ourselves. We have identified that in this case we don't have two terms, rather we have three different terms. So our first thing will be for us to get the GCD of all the three terms in this case. And our first term being a 3a, 9b, 36. So we're going to look at our number which can be able to, the smallest number which can be able to divide all the three numbers. So the first case, we are able to divide all the three numbers by 3, where 3 will divide 3a, a times, 3 will divide 9b, 3b times, and 3 will divide 36, 24 times. Now, there's no any other number that can be able to divide all the three numbers, that is the three values which we are having, a, 3a, and 24, meaning that our GCD in this case will be the 3. So what you're going to do is you're going to take the 3 that we are having and divide it by every term in our algebraic expression, which is 3a plus 9b minus 36 divide by, let me increase the size of my handwriting, 3a, 9b, 36, divide this term by 3, divide this term by 3, and divide the third term by 3, and we also repeat by multiplying everything by 3. So on simplification, this 3 will drop off this 3. This 3 will divide this 9 3 times, and this 3 will divide 36 24 times, so that your final expression after simplification becomes 3 into bracket a from what we are left with after the division of the first term, now plus the addition sign. The second term, we divided 3 by 9 and we had a 3. Now 3 times b, you're going to obtain 3b, and subtraction sign. And the final third part, we are having 3 divided by 36, should be 1, 12, 112 times. So this becomes our final expression on after we've simplified this algebraic expression with 3 terms. So we have done a lot of examples on simplification of algebraic with 2 terms and 3 terms. Basically, they are just the same thing. We are repeating ourselves. The first thing is get the GCD of all the terms that are available. After you've obtained the GCD, you divide every term in your expression by the GCD and also multiply everything by the GCD. I'd like us to move to our final part, which is a little bit different from what we've been doing, factorization of algebraic expression with 4 terms. So factorization of algebraic expression with 4 terms is a little bit different from the first 2 cases which we have been looking at. And in this case, I'm going to use this example here. I'm going to use 2 examples. My first example will be x. Okay, so plus 2xy, then plus 5a plus 10a y. Okay, so when you're factorizing an algebraic expression with 4 terms, the first thing is not for you to get the GCD, unlike the case of algebraic expression with 2 terms or 3 terms. So in this case, first of all, we have to break down our algebraic expression into a simple version. So what we're going to do is we're going to pair the first 2 terms and also pair the last 2 terms of our algebraic expression. If I was to take you back, what we are doing is we are repeating the same process with what we did on long division, getting square root of numbers using the long division method back in grade 7. So we are going to break our algebraic expression into 2, where we have this first part. The sign will be the sign in between, which is an addition case for this matter, and the other 2 last terms will also give us another part of our algebraic expression. So once you've broken your expression into 2 parts, you factorize each part independently. So I'm going to begin by factorization of this part here, then proceed ahead to factorization of that other part. So from this part, if I was to have that expression here, I have 2 terms now. Now what I'm going to do is I'm going to repeat on factorization of expression with 2 terms, which will be to obtain the GCD of the 2 terms here. So from my GCD table, I have an x and I have a 2xy. So an x is appearing on the first term and also another x is appearing on the second term, meaning an x is a common term that can divide the 2 parts. X will divide x once and x will divide 2xy, 2y terms. Meaning, in this case, your GCD will be equivalent to x. Once you've obtained the GCD, you now you divide every term in your expression by the GCD, which is x plus 2y as our expression. Divide everything by the GCD. So the first term divide by x, also the second term divide by x, and you also multiply everything by the GCD, such that this x will cancel off this x on simplification, and also this x will cancel off this x. So on your simplified version of your first part, you're going to have an x into bracket 1 plus 2y as your first expression from simplification of the first part. We are going to repeat the same thing on simplification of the second part here, which we are going to have, we are going to obtain the GCD of now these 2 terms. So we are having 5a, 10ay, So our second term, the second pair, we're going to get the GCD. Now the smallest number, starting with the numerical value, that's a 10 and a 5. Of course, a 5 is the smallest number which can divide both the two parts. So 5 will divide 5a, a times, and 5 will divide 10a, y, 2a, y times. Now, if I was to look at that part very keenly, I can see there's an a here and another a here. On the non-numerical values, there's an a which is appearing on the first part and also another a which is appearing on the second part. Meaning an a can be used to remove or to divide both the two parts. So if I was to have an a here, a will divide a once, and a will divide 2ay, 2y times, because the a will cancel out that a. Now your GCD in this case will be the product of these two values here. So your GCD, we are going to obtain it from your GCD, are going to obtain it from the product of these two parts, which is the multiplication of 5 and a, to give you a 5a as your GCD. Once you obtain the GCD, you are again going to divide each of the two terms by the GCD in this case. So your first term was 5a plus 10ay. So that was the original expression, and we're going to divide it by 5a, which is now the GCD in this case, and also multiply everything by the GCD. So we are going to have a bracket and insert a 5a outside. So this 5a will cancel out that 5a. 5 will divide 10 two times, and 5a will cancel off a, so that on simplification this expression comes out as 5a into bracket 1 plus 2y. Now, once you're done with the simplification part, we are going to recombine our expression. Remember, in our first part, we had broken our expression into two parts. So in this case, we are supposed now to join them together, recombine. And we're going to make use of this sign in between, which was an addition sign, to recombine the two expressions that we have obtained from factorization of the first part, this expression here, and factorization of the second part, this expression here. So if I was to recombine the two expressions, I'm going to end up with the first part will be x recombining the two expressions. The first expression from this part was an x plus 2y, and the second expression plus, now the sign in is coming in from this sign that we had here. So if it was a subtraction sign, automatically this part will become a subtraction sign. But in this case, we had an addition sign, so this part is going also to become an addition sign. Plus the second part, this side here, so that's a 5a Okay, now once we have recombined the two expressions, if you've done the factorization very well, usually what's supposed to happen is the parts that are enclosed in the bracket are supposed to end up as identical parts. So what we do, because we're having two identical parts, we drop off one. So in this case, I'm going to drop off the second part. And what I'm going to do is I'm going to take my first coefficient on the first side of the bracket, which is an x. Then the other part, I'm going to have it at the second coefficient from the second part, plus 5a, and close the two parts in bracket. And the other bracket which I did not cancel it off, we don't talk of cancellation, rather the one which I did not ignore of this case will be a to y as the other part. So on factorization, this becomes the expression, which is now a factorized version from this expression here. So if you are given an expression and you are asked to factorize it out, so the first thing is for you to identify how many terms are in that expression. if it's an expression with 4 terms, the first thing is you're supposed to break that expression into 2 parts. In this case, we have this one at the first part and this part at the second part. Once you've broken the expression into 2 parts, you factorize out each part independently. So it indicates that if you are to factorize out an expression with 4 terms, first of all, you have to understand how do you factorize an expression with 2 terms. Because once you've broken the expression into 2 parts, you're going to have an expression with 2 terms and also the other part with the expression with 2 terms. So to begin with, we are going to get the GCD of these 2 terms here. So from the GCD table, we've obtained our GCD as x. Then once you have the x, now you divide every term by the GCD. X divided by x, 2xy divided by x. You also multiply every term by the GCD so that we don't change the value of the expression. So we are dividing and multiplying by the same thing so that we do not change the value of the expression. Now on simplification on the content inside the bracket, this x will cancel off this x to end up with a 1. This x is going to cancel off this x to give you a 2y. And on the second part, still you're going to do the same. So obtain the GCD of the 2 terms. Our GCD in this case, you've obtained it as 5a. And you divide every term by the GCD. And you also multiply every term by the GCD. So on simplification of the content inside the bracket, you're going to get that your GCD is going to be, your factorized expression from the second part will be a 5a into bracket 1 plus 2y. Once you have the 2 expressions, you now recombine them. And for you to recombine them, you consider which sign was in between when you had the 2 parts paired. So in this case, our sign was an addition sign. We're going to end up with also an addition sign. So you're going to have a first expression, which is x into bracket 1 plus 2y, which we have written here. Then an addition sign comes in between and our second expression. Now, once you've obtained the 2 parts, you ignore one of the parts because the 2 parts are supposed to be identical if you are to factorize out the 2 parts very well. So if you get to this part and you realize that the 2 parts are not identical, it means you are having an error and you have to go back to your work. So once you're done with the cancellation of one of the part, the bracket which is identical, you're going to pick the coefficients of the expressions that are outside and join them to give you another pair, and the other bracket which you didn't cancel it out, we're going to make use of it as our second pair, and this becomes our final expression on factorization of algebraic expression. So that marks the end of our class, but to give you an overview, algebra is a very easy strand which has a lot of application. So as we are going to look at later, we are going to look at some of the application of algebraic expression, but I want to look at something a bit different on this part here. In this case, we had an algebraic expression with 4 terms, but all the signs were positive. That is, all the signs in that expression were addition sign. We had an expression with this nature, x plus 2xy plus 5a subtract 10ay. Not subtract, addition. So that was the kind of the original expression that we had, and we've seen how to factorize it out when everything is positive. All the signs are addition sign. What if we had some subtraction sign in between? So what if this sign was a subtraction sign, this sign a subtraction sign, and also this side as a subtraction sign? How then do you factorize this, that expression? So again, what you're going to do is you're going, of course, to repeat what we did. So the first thing will be for you to pair up your algebraic expression. And in that case, I'm going to have a bracket here. But in the second case is, if I'm going to have a bracket here, then this sign has to change. The reason is we are trying to keep or to we are trying to have our rules of integer, which was our strand 1, to hold, so that this part, you see, if you're going to have this part as, if you're going to insert brackets here and brackets here without changing this sign here, when you're doing the opening, you'll have changed actually the sign of this part. So we know that -1 times -1, you're supposed to end up with a +1 from the strand of integers. So in this case, when you're doing the pairing of these two parts, the second sign has to change from a subtraction sign into an addition sign, so that the correct version of that expression, when you pair terms up, this one is going to still remain a subtraction sign into bracket 5a plus 10ay. So this is the correct version. This sign is going to change from a subtraction sign to an addition sign, because this rule has to apply. -1 times 5, you're going to have a -5, and also -1 times 10, you're going to have a -10. Then once you've paired up your expression, what you're going to do is, we are going again to factorize the first two terms independently and also the second two terms independently. So to redraw our table for getting the GCD, x, 2x, y. So your common term in this case is x, 1, 2, y. So your GCD in this case will be x divided by x, subtract 2xy over x, multiply by x, x into bracket 1 minus 2y. The second part, 5a. So we had obtained already our GCD as 5a. I'm not going to repeat it, but for the interest of maybe the learners who have joined in, 5a, this will be 2ay, a, this will be 1, 2y, this is 5a. So as our GCD is 5a, and 5a plus 10ay, divide this side by 5a, 5a, 5a. So this and this is going to cancel out. This part is going to give you a 2. So from those two parts, you're going to get your first expression as x into bracket 1 minus 2y. Now, in this case, our sign is not going to be an addition sign. Rather, it's going to be this subtraction sign here. So subtract our second expression, this expression here, which is a 5a into so we're having a 5a into 1 subtract 2y. So again, once you're done with the factorization, you're supposed to see that the first part, the bracket of it, and the second part, the bracket part of it, are going to be identical. And in this part, we are going to cancel off the second part or ignore it off. So your first expression or the first content will be this term here, the coefficient of the first bracket, and the coefficient of the second bracket together with the sign of it is going to give you the first pair of the bracket, and the second bracket is going to be a 1 minus 2y as our second part. So that marks the end of our class, and we are done with the factorization. So in this class, basically, we have been looking at how do you factorize an algebraic expression with 2 terms, with 3 terms, and also with 4 terms. So we have said factorization of algebraic expression with 2 terms is the same way as factorization of algebraic expression with 4 terms. So with that marks the end of our class, and thank you for attending my class. Have a good day.